Good morning, guys. So today I'm going to make a video about physical and chemical changes, and most of this is a review from sixth grade. But there is a piece um, that we're building off of for eighth grade to finish off our chemistry unit this year. So in sixth grade, all you had to do was identify whether or not a substance went through a physical or a chemical change. But in eighth grade, we're going to investigate what the evidence is. What are the clues that tell us that a change occurred? Okay. So we've been talking about how substances go through changes in chemical equations, and we've been learning about how to balance those chemical equations and how to determine whether or not those equations follow the law of conservation of mass. So now we're going to be moving into what are the clues that we would need to look for to say that yes, a chemical change occurred, or no, it was just a physical change. So this is kind of us being detectives and looking for clues. And just like a regular detective, whenever they're trying to solve a crime, um, they can't just look at one piece of evidence to say whether or not somebody is guilty or not guilty. So, for example, if a store gets robbed and the police come in and dust for fingerprints, they're going to find fingerprints of 100, 200 people that have touched different things inside the store. So if they pull one fingerprint and they match it to somebody else, they can't just use that one little piece of evidence to say that that person is guilty, right? So, same thing with chemical reactions. We cannot just take one piece of evidence to say that a chemical reaction occurred. Okay, so again, this is to review the sixth grade stuff that you learned, and then eventually we will be talking about what the evidence is that we're looking for chemical reactions. So first thing, of course, we need to understand is because of the law of conservation of mass, matter can never be created or destroyed. All it can do is change form. So everything in the universe, whether it's the table that you're sitting at, the water that you're drinking, the food that you ate, the car that you're riding in, the materials that your house are built, they're all made of atoms that have been around forever. And then when all is said and done, if they eventually tear down your house or your car gets in a wreck and you can't use it anymore, the parts of that car are going to be reused somehow, either by people or nature is going to take those atoms and use them for other things. Okay, so first thing we need to understand, of course, is that all matter undergoes changes all of the time. And there are two different types of changes. There's physical changes, and this is when substances just go through a physical change, but they don't change what they're made of. So, for example, in the picture, you see icicles, you see clouds, you see a lake. So, those are the three different type phases of matter for water. Water can exist as a liquid, it can exist as a solid, it can exist as a gas. But no matter what, it's always still water. It's still H2O chemically, right? So, it can go through changes, but still be chemically the same substance. Okay. And then, of course, there's chemical, and you see some flames there because usually, a lot of times, chemical changes occur when things burn. So here's some examples of some physical changes. You've got some wood being chipped up. Um, you've got, of course, ice melting. You've got clouds forming, water evaporating. Those are all examples of physical changes. You can chop wood and make it smaller, but it's still wood. You can take paper and tear it, but it's still paper. It just looks different. So there's all different types of physical changes that don't change the chemical makeup of the substance. So again, physical changes occur when the appearance of a substance changes, but chemically the substance is still the same. So again, that picture of the iceberg is made of H2O. The liquid water that it's floating in is made of H2O. They just have a different appearance. So the molecules of that substance do not change. So some examples of physical changes, of course, melting and freezing. The water cycle is completely a physical change from liquid to gas to solid and back to gas and back to liquid, back and forth. That behavior of water is all physical changes. So any change in size or shape would also qualify as a physical change as well. So a physical change occurs, again, when substances are mixed and something dissolves. So, for example, Kool-Aid. Kool-Aid is a physical change. So you take water and you take a powder and maybe some sugar. And when you put the powder and the sugar into the water, it changes it. Okay, it changes the color, it changes the taste of it. But you can separate those three things from one another. If you put Kool-Aid in a pot and boil it, the water will evaporate out of the pot. But in the pot, the sugar will still be in the pot, and the coloring and flavoring from the Kool-Aid powder will also still stay in the pot. So when things dissolve, we can put sugar in water, and it seems like it disappears. But all it is dissolving inside and fitting in between the water molecules, but it doesn't actually chemically bond with the water molecules. So it's still a mixture, right? It's a mixture of things, but chemically they have not bonded together. A salad is also an example of a mixture. You can put lettuce and tomatoes and bacon bits and dressing on the salad, but you could separate all of those things if you had the patience to do so. So water, salt, and sugar still keep original properties, and you can separate those substances again. So again, to review, physical changes are just changes in the appearance of an object or a substance, but chemical changes are something a little bit different. A chemical change occurs when the atoms making up the matter rearrange. And so, like we've shown in chemical equations, the atoms of two substances will break apart, rearrange themselves, and create new substances on the right side of the equation in the product side. Okay, so this is a change at the atomic level, molecules breaking apart, rearranging, and creating brand new substances. So what we end with chemically, the formula for what we end with is different than the formula for what we started with. So the new substance is chemically brand new, and it has different properties. So again, one of the other examples that we talk about is salt. So salt is made up of sodium and chlorine, and we put salt on our food and eat it. But sodium by itself is a silver metal that will spark if you throw it in water. And chlorine is a green gas that would kill us if we inhaled too much of it. So you take this silver solid that explodes in water and mix it with and chemically bond it with this poisonous deadly gas, and then you get something entirely different that we can put on our food and it not harm us. Now, of course, if we have too much salt in our diet, it can cause hypertension, high blood pressure, those kinds of things. But by itself, chlorine would kill you, but when we bond chlorine with sodium, it wouldn't. And so that process of changing substances from one thing into another is what a chemical reaction is. So what is the evidence? So what would we be looking for? And this is the 8th grade part. What would we be looking for to say that a chemical reaction or a chemical change occurred? So the first thing we'd be looking for is production of a gas. So since most gases are invisible to the eye, there's other clues that we need to look for to say that a gas is being produced. One of those things is bubbles. So bubbles show evidence that a gas is being produced. The other thing that we'd be looking for is an odor. So when you burn a match or when you cook, your house gets filled or your kitchen gets filled with this odor that is given off. And so that is also evidence of a gas being produced. So you're looking for bubbles, you're looking for fizzing, you're looking for an odor. Those are all evidence that a gas is being produced. So again, bubbles, fizzing, foaming, smoke, odor, those are all evidence that a gas is being produced. Now, color change is a piece of evidence, but it's not a one thing that you could say is the evidence that you need. Very similar to the example I used at the beginning. A police detective cannot walk into a store and lift one fingerprint and say without a doubt 100% that a person caused that crime or committed that crime. So when you see a color change, it doesn't necessarily mean by itself that a chemical reaction occurred, but it is a piece of evidence that if you see a color change and you see bubbles, now that's more than one piece of evidence. And that's the same thing that police detectives look for, is more than one piece of evidence to show that somebody committed a crime. So again, color change can be used as evidence, but by itself is not enough to say that a chemical change occurred. So again, not all color changes are chemical. Now this is the one that a lot of 8th graders struggle with, and that's the formation of a precipitate. And a precipitate is when a solid forms when you mix two liquids. So if you take two liquids and combine them and a solid forms from that, that is evidence that a chemical reaction or a chemical change occurred. Okay. So again, and maybe it's because of the word that a lot of students forget, and because a lot of the chemical reactions that we do in class don't have a precipitate forming, but precipitate, or the formation of a precipitate, a solid being created when you mix liquids, is also another piece of evidence. So any type of cloudiness, if it's foggy, if you see a solid forming at the bottom of a container, those are all what we call precipitates. And again, that is another piece of evidence that a chemical change or reaction occurred. So any kind of change in temperature. So some reactions are what we call exothermic, which means they give off heat. Some reactions are endothermic, which means they absorb heat and they feel cold. So, for example, you can go to CVS, Walgreens, HEB, and you can buy these cold packs that when you get the bag, it feels at room temperature, but if you twist it and break the compartments that are inside of it and mix the chemicals, it can get cold. That would be an endothermic reaction. And there's also heat packs, kind of the same thing. You can buy little hand warmers at Academy that if you expose it to air, they come in a little plastic bag, but when you open the bag and expose it to air, there's a chemical reaction occurs that causes heat to be given off, and that would be an exothermic reaction. Of course, firecrackers, burning of a match, digestion. I think that's why the skunk is in that picture. And then also glow sticks. So when you break a glow stick, there's a container inside of another container. And when you bend those sticks and break the container inside and the two liquids mix, it glows. And so that also is an example of a chemical reaction. Sparking, exploding, glowing, these are all examples of evidence of heat or light. So temperature increasing or decreasing, something getting cold, something getting hot, those are also evidence of chemical reactions. So again, these are only clues, and just like a police detective, you have to kind of piece the clues together ultimately to decide whether or not a chemical change occurred. But the biggest thing that you have to understand is that a chemical change always occurs if you have a brand new substance. If what you started with is different than what you ended with, then a chemical change did occur. So that's the biggest piece of evidence right there, that a new substance is formed. So here are some common examples of chemical changes. Rusting, iron and oxygen mixing, creating iron oxide is an example of a chemical change. We can clean the rust off of things, but it's never going to be as strong as it was before. Tarnishing, you look at the Statue of Liberty there, it's green. That is not the original color. When France gave us the Statue of Liberty, it had more of a copper coloring to it, but over the last 200 years or so that it sat out in New York Harbor, exposed to the humidity and the water and the rain and the weather, it's tarnished to this green color. Pennies, coins, mostly pennies, can tarnish. You can clean that stuff off, but again, it is deteriorating the actual molecules and atoms that are made up in those substances. Burning is always going to be a chemical reaction. So anytime you burn something, that will be a chemical reaction because you can't get it back. Once you burn wood, you can't get that wood back. You can't reverse the process. You create a brand new substance. Ash, coal, carbon dioxide, those kinds of things are created when you burn something. Digestion, always in your body, is a chemical reaction, chemical change. What comes out of your body is definitely different than what went into your body. So every day in your stomach and in your intestines, there are chemical changes taking place that, again, proving that what you're getting out of it is not what you put into it. So if you have the chemical equation, you can tell if a chemical change is taking place by looking to see if the products in the equation are different from the reactions or the reactants, okay? And so we've done enough of those chemical equations to kind of show you how that works. So again, here's an example. You've seen this picture before. This is the combustion of methane. So if we take methane, CH4, and have it react with oxygen molecules, the substances that we get on the right side, the products, are atomically different. Okay, so they're the same numbers of atoms on the left as there are on the right, but they have broken apart and rearranged to form brand new substances. So this is the ultimate evidence that a chemical change or chemical reaction occurred, is ending with different chemicals than you started with. And so here's some other examples of hydrogen and oxygen forming water, sulfur and oxygen forming a sulfate, mercuric oxide breaking down into mercury and oxygen, zinc and hydrochloric acid forming zinc chloride and hydrogen gas. And then you've got sodium and water reacting to form sodium hydroxide and hydrogen gas as well. Okay, so again, this is just kind of a quick overview of both the sixth grade information about the difference between what a physical and a chemical change are, and also the evidence of physical and chemical changes. So as you become those detectives and try to figure out whether or not something has gone through a physical change or a chemical change, remember you're looking for evidence of that. And the evidence, again, is the production of a gas, a temperature change, light given off, the formation of a precipitate, and a color change. So you're looking for multiple pieces of evidence to say that a chemical change occurred. All right, guys.